Rational exponents. Here's a little note to help you get started. Rational numbers are fractions. Remember that from the beginning of chapter 1. Well, rational exponents are exponents that are fractions. Exponents that are fractions represent radicals. Did you get all that? Hopefully this video will help you understand that a little bit better. Combine the radical expressions if possible. Well, we've learned how to simplify these using that prison method. If you don't remember that, go back to one of the previous videos. If you break down this 12 into its prime factors, let's just say that's 2 times 6. 2 is prime, but 6 is not. That's 2 times 3. So this is the same thing as 2 times 2 times 3. Well, if you use the prison method, since this is a square root, they escape in pairs. So these two escape, but when they escape, only one survives on the outside. So the square root of 12 is 2, and then the square root of 3. Since 3 didn't have a partner, he had to stay in prison. Okay, how about the 18? We have 18, let's just say that's 3 times 6. 3 is prime, 6 is 2 times 3. Again, they must escape in pairs, so these 3's get to pair up, but the 2 has to stay inside. So we have 1 3 on the outside and a 2 on the inside. Okay, do the same thing with the 27. Let's say that's 3 times 9. So 3 times 3 times 3. Well, here, these two pair up and get to escape, but this little guy doesn't have a partner. So we have 1 3 on the outside and 1 3 on the inside. Whenever you are adding or subtracting radicals, the radical parts must be the same. That means this term and this term can be added. 2 square roots of 3 plus 3 square roots of 3 would be 5 square roots of 3. This doesn't have a like term, so we just bring it down. All good? Okay, how about this one? We have 3 x's, 6 y's, and a z. That would look something like this. 1, 2, 3, 1, 2, 3, 4, 5, 6, and a z. Now this one is a cube root. Since it's a cube root, they must escape in 3's. So we group them into 3's, and only one from each group will survive. So on the outside of that radical, we're going to have an x and 2 y's, and on the inside, we're going to have a z. So this first radical simplifies into x, y squared, the cube root of z, plus, okay, the next one we have the cube root of z. Well, this can't be simplified anymore because there's only one z under there. So we're going to have 4xy squared cube root of z. Now, notice first of all that these radicals are the same. Cube root of z, cube root of z. But this one even has variable parts. Now remember, for terms to be alike, the variable parts have to be the same also. We do have an x, and we do have a y squared and a y squared. So these two terms can be added. We have 1xy squared cube root of z plus 4xy squared cube root of z. That would give us 5xy squared cube root of z. Now when you're entering your answers into the Hawks learning system, make sure you're really careful about these two things here. The placement is very, very important. Okay, how about the next one? We have the square root of 4 over 36 plus the square root of 3 over 5. Well, the square root of 4 over 36 is easy. The square root of 4 is 2, and the square root of 36 is 6. That reduces to 1/3, but I'll do that in the next step. But then we have this 3/5 over here. What are we going to do about that? That's the same thing as the cube root of 3 over, the square root of 3 over the square root of 5. Now remember, to rationalize the denominator, you would need to multiply this by the square root of 5 over the square root of 5. That would give you the square root of 15 over the square root of 25, which is the square root of 15 over 5, because the square root of 25 is 5. So this one would be square root of 15 over 5. Now if we want to add these together, we need to have common denominators. I think I'm going to need a little more room. Okay, I made some room here. Now let's see what happens. The common denominator would be 30. Six times 5 is 30, so 2 times 5 is 10. And then 5 times 6 is 30, so the square root of 15 times 6 is 6 square root of 15. Well, now we can combine those. That would be 10 plus 6 square root of 15 all over 30. I really do need some more room on this page, don't I? Alright, at this point, we can factor a 2 out of the numerator and then reduce it even further. So let me make a tad bit more room, and we'll do that here. Okay, so if we factor a 2 out of this, we end up with 2 times 5 plus 3 square root of 15 all over 30. Now you can see 2 will go into 30 15 times. So your answer will be 5 plus 3 square root of 15 all over 15. Rational number exponents. First we want to talk about the meaning of a to the 1 over n. If n is a natural number, that just means 1, 2, 3, 4, 5, like that, the counting numbers. And if the nth root of a is a real number, that just means you can actually take the nth root of whatever a is, then a to the 1 over n is equal to the nth root of a. I'll explain that more in just a second. Okay, how about a to the m over n? Pretty much what I want you to get out of all of this is the denominator is your index and your numerator is your power. Okay? You can write it this way or you can write it this way. Either of those is okay. So if I wanted to rewrite this problem in the form a to the m over n, it would look like this. 144 to the, remember this number is your denominator, so it's something over 3. Does this have a power? It does not. It's just 144 to the 1/3 power. If you wanted to take it a little bit further, you could. 144 is the same thing as 12 squared, right? 144 is 12 squared to the 1/3 power. Now what do you do with a power to a power? Don't you multiply the powers? So you end up with 12 to the 2/3 power. For this particular problem, I think you could have just stopped here. I'm not really sure what the software is asking you to do, but if you just rewrite this into the form they're asking, it would just be 144 to the 1/3 power. So how about the 6th root of 81? Let's go ahead and make this a little bit more interesting. 81 is the same thing as 9 squared, right? So this will be 9 to the, this is your numerator, this is your denominator. And if you reduce that, you get 9 to the 1/3 power. Okay, so this says simplify each of the following expressions, writing your answer using the same notation as the original expression. So if we were to simplify this first one, that's 32x to the 2/5 power. Remember, this is your index, this is your power. So that's the 5th root of 32x all squared. Now remember, you could square underneath the radical or you can square outside. It doesn't matter, either way will work. So how does this work? What is the 5th root of 32? If you were to break this down, 32, that's 4 times 8, 2 times 2, times 2 times 2 times 2. So you have 5 2's. Since this is the 5th root, all 5 of these get grouped together, but only one survives. So the 5th root of 32 is 2. But you still have the 5th root of x because it doesn't have any partners. And this is all squared. Now there are many different ways to go about this problem. This is just one of the ways. Now we need to square this whole thing. Well, 2 squared is 4. And the 5th root of x squared is just that. It's the 5th root of x squared. Now they want it to be written in the form that it was originally written in. So that means writing your exponent as a fraction. So we have 4 times x to the, this is your power or your numerator. This is your index or your denominator. So x to the 2/5 power. Okay, how about b? We have the 4th root of 16a to the 6th. Break down the 16. That's 4 times 4, 2 times 2 times 2 times 2. So all 4 of these get grouped together. Then you have those a's. 4 of those get grouped together and 1 survives. But these 2 have to stay on the inside, right? Okay, so the 2's get to escape into just 1 2. These 4 a's escape, only 1 survives, but then we still have the 4th root of a squared. Now this particular problem was not written with your exponent as a fraction, so we can just leave it like this. Okay, how about c? 2a squared minus 6 to the 1/2 power times 2a squared minus 6 to the 1/2 power. Let's do something a little bit easier first. If you have x to the 1/2 times x to the 1/2, what do you do with those exponents? Do you remember this? If you have x squared times x cubed, that gives you x to the 5th power. You just add them together. Well, what's 1/2 plus 1/2? That would just be x, right? This is exactly the same as this one. You have something to the 1/2 times something to the 1/2, which just means you add the exponents. Well, 1/2 plus 1/2 is 1. 2a squared minus 6 to the 1st power. Well, that simplifies into 2a squared minus 6. Okay, we have 2 more. The cube root of the cube root of x. Well, on the inside, we have x to the 1/3 power. But all of that is also under a cube root. So all of that is to the 1/3 power. So this would be x to the 1/3 to the 1/3. Well, when you have a power to a power, you're supposed to multiply the powers. That would be x to the 1/9 power. To write it in the form it was in originally, this would mean the 9th root of x to the 1st power. So you just say the 9th root of x. Alright, so how about the next one? Remember, when you have a negative exponent, it means you just flip it over. So you move this part to the other side. That leaves you with a to the 1/3 times a to the 2/3. Well, what do you do when you have something raised to a power times the same base raised to a power? You add the powers, and that gives you a to the 3/3 or